Hi, I'm Jonathan. This is an update for the Angel Eye Roadway Guardian. As a reminder, I'm working on a way to build a two-axis servo turret that will highlight different dangerous parts of intersections in real time. In a previous deliverable, I showed this technology map. And so right now I'm zeroing in on the upper right, where we can output via the pointer servo. I'm using light and also possibly sound. Here's a mock-up of what I'm hoping to achieve. On an intersection, I'll be able to use the turret to then mark or kind of paint different types of pedestrians or cyclists as they move about a roadway intersection. So I've been working with a Tesla board. That's new for me, having worked with hardware. I managed to get blinky lights and even to get the servo to start moving at specified increments. What I needed to do then was to figure out the range of motion of the servo, and then to set up a way to precisely position the servo for specific amounts of degrees. So the setup that I have is a protractor and a pencil and a very cheap plumb bob. And so I can send a position command to the servo and then measure what the corresponding movement in degrees is. So from this, I can assemble a table and then perform an interpolation between all the measured calibrated points to kind of infer between these points what a specific angle can be. So here's a blowout of the measured data and the interpolated values between them. I use this script to measure each precise position value, so like 0.95 as an arbitrary position from between 0 and 1, and the resulting degree, and then started to turn that into an association table, which I have 3 values here. I use Python and NumPy because it's quick at doing the interpolation that's needed, and I will have to do eventually 2-dimensional interpolation. I started to an attempt at loading the Python file and basically shoving that onto the Tesla board, but it did not work. What I'm going to do is to set up an MQTT broker that is a bridge between the laptop and then sending messages to the Tesla to orient the servos. For the 2-axis gimbal system, I'm going to probably do a fallback for hand calibration via a projected grid. I have to find out also if the third-party cloud-based MQTT server will run fast enough. If it doesn't, I'll have to run the server locally and figure out some of those details. There's some risk associated with getting real-time data from upstream parts of the system that a colleague is working on. So if I can't get that real-time data, I'm going to have to get some hard-coded pre-baked data. A fourth risk is if I run into difficulties getting the 2-axis servo system to work properly, or if I get it to work really quickly, then what I want to do either way is to build a projector system that will be able to display animated vector graphics projected onto a mock-up of a city intersection. I intend to use paper.js framework to perform this. So the next steps are to perform the calibration of the dual servo system and then set up the MQTT messaging queue. After that, then I can focus on the specific scripting for the demo and possibly the stretch goal of using a projector system with animated graphics. This is Angel Eye. I look forward to your comments and input. Thank you.